For organic liquids in IR spectroscopy, a common preparation is to use what's known as salt plates. Salt plates are usually found in this little tin, and this tin is found in the desiccator in the back part of the laboratory. These are truly salt plates in that they're made from sodium chloride, and that's why we don't want to get them wet, and that's also why we store them in a desiccator, which is a moisture-free environment. There's usually about 4 to 6 of these in this tin. I'm just going to choose these 2 that are in here now and inspect them, make sure they're reasonably clean and smooth and not too damaged, and they look good enough. So I'm going to go ahead and put that cover back on and put the plate in the middle part of this video so we can see it. The compound that I have for you is limonene, which is a nice smelling oil that was prepared by steam distillation. And I'm going to use a new pipette to take about a drop's worth of this limonene onto the salt plate. And that's hopefully all we need for this preparation. Okay, so I've got a drop on there, and I'm going to press down on the top plate. Looks like it's not fully covering the bottom plate, so I'm going to want to put another drop on there. Make sure there's no air pockets in your sample. Okay, we'll try this. Okay, that's a lot better. And the last step is just simply to take this holder, plop these plates inside, clamps down, and that's good to go for our IR. For organic solids in IR spectroscopy, it's sometimes necessary to prepare what's known as a KBR pellet. I've got the KBR powder out. Make sure you keep the cap on as much as possible. It tends to pick up moisture because it's hygroscopic. The compound that I'm going to prepare as a KBR pellet is called 4-bromocetophenone, and this is a solid. And the first critical step is to just get a tiny amount of sample into the mortar and pestle. This mortar and pestle that I have out here is very expensive. It's made out of agate. You can find this usually in a black suitcase in one of the cupboards in the back part of the laboratory. This is the real trick. So I'm going to try to get the tiniest amount that I can get in here. And the tendency of students when they first start making pellets is to get too much sample into the mortar and pestle. That's almost too much right there. We'll see how this goes. It might be necessary to get a chem wipe and wipe out part of this. So I'm going to go ahead and just make this as smooth as I can with the mortar and pestle. The reason why we use agate is because it's nice and smooth. It really crushes down these samples to a fine powder. Okay, it looks like I've got a wee bit too much in there, so I'm going to go ahead and wipe out about half of this if I can. Okay, that looks pretty good. Now, what I've also done ahead of time is measure out 0.12 grams of this KBR powder, although you'll want to measure that right before you use it because it's hygroscopic, it'll pick up moisture. And this is on weighing paper, so I'm just going to go ahead and slide this in. So once again, that's 0.12 grams of KBR powder. For this, I'm not going to try to crush this to oblivion. I'm just going to try to mix it in with my sample, a uniform mixture as much as possible. Okay, once I feel like it's mixed thoroughly, I'm going to try to push all the powder to the middle. I'm just going to simply dump this back onto weighing paper. So this is my original weighing paper. Out it goes, right back onto the paper. Okay, so the next step is going to be setting up the die set for the press so we can press this into a pellet. I've got my mixture already made. This is a mixture of my compound and the KBR powder. It's on weighing paper currently. I've got out the die set. This is the base of the die set, and the first thing you want to put on this is the outer jacket. That goes on like so. There's 2 of these little dies right here. There's 2 sides to them. There's a sharp side and there's a beveled side. The beveled side faces downwards when you first put this bottom die in. It gets a little bit stuck at the top, so you just have to force it in there with your thumb or the plunger. I'm going to transfer my solid at this point into the middle chamber. So this is the mixture I made before. Okay, it's not really filling out the bottom part of it, so I'm going to want to tap this a little bit just to spread it out, make it a little more even. Okay, so now it's roughly covering the bottom part of this die set. The second die with the sharp side facing downwards, I'm going to put that in at this point. The bevel side's facing upwards. And the last little piece, of course, is the plunger. The plunger, I like to put the sharp side downwards. And this is now ready and assembled for the press. And once we press this powder inside here under extreme pressure, it's going to form a little KBR disc, and I'll show you that when it's done. I've just transferred my mixture into this die set. I'm about to put it into the press. And try to position the die set in the middle part of this base plate. And there's some circles on top of this base plate that allow you to kind of position that properly right in the middle. And I'm just going to use this small little lever to jack it up a little bit, just like a car jack, until it catches. And once I feel a little bit of pressure, I'm going to go ahead and close the safety hatch. Just double check it one more time, make sure it's roughly centered. And it looks like that's the case. Here comes the sissy bar. This puts a lot more leverage onto this bar. And you want to jack this up to about 20,000 pounds of pressure. Don't go beyond that. There it is, 20,000 pounds of pressure. You can take this out at this point. And we're going to let this sit here for 2 minutes, and not too much longer than 2 minutes, because at that point our pellet should be okay. Now with all this tremendous pressure, what's happening is you're actually melting the KBR powder along with your sample, and by the time we release the pressure, it's going to solidify into a nice KBR pellet. That's why this is called a KBR press. Okay, so 2 minutes is up. We're going to retrieve the sample, and we're going to use this little knob, just like on a car jack again, to release the pressure until it just releases. Make sure you turn this off though, back to the right, so that the base plate does not go all the way down to the bottom. That way the next person coming along doesn't have to jack this way back up. And that's all we need to get this back out of here. So this just slides out. I'm going to show you now how to retrieve the pellet in the inside of this without cracking it. I just retrieved my sample from the KBR press. I'm about to disassemble this die set, and my sample's, my pellet hopefully is in the middle part of this. So what I'm going to do is I'm going to try to just hold this and flip it over and see what happens. Sometimes it's going to be necessary to use the press again to retrieve the pellet, but it looks like it's going to come out okay. So the plunger is just going to push those dies right out of the middle part of it. I'm going to very carefully take the top die off, and here's my pellet. I can see it on top of the bottom die. So it looks like it's okay, and I'm just going to push this to the side real quick. And we've got these new magnetic pellet holders that I'm going to show you. And I'm gently taking off my little pellet off the die, and I'm going to position this pellet right over the center part of that hole on the new holders. And I just realized that I put it on top of the magnet, so I'm going to have to take this off carefully and try this again. Okay, here we go. That's better. So note, take magnet off first. Pellet goes in that little hole, nice and neat. Magnet goes on top of that. That just holds the pellet in place. And there we have a pellet. So I'm going to bring this upwards a little bit towards the camera, see if we can get a better view of this. That's a decent looking pellet. It's not too cloudy. It's transparent. That should work okay on the IR instrument. We're at the IR instrument. We've already prepared a KBR pellet previously and a liquid sample. Remember, the liquid sample was placed between two salt plates. We've got it in the holder. And to collect the data for this sample, it's really straightforward. You just take the plate and slide it into one of the many available slots, and that just slides into place. You close the hatch. Does not matter in the slightest which of these slots you place this into, but once it's in there, you're going to collect your data, and that's the end of that sampling technique. The pellet is just as easy. So you take the pellet that we just created, you slide it into any slot that you want to. It doesn't matter. You collect your data, and that's it. Pretty simple. The hardest part about this is preparing the pellet. The actual data collection is pretty easy. Now, most of the time we run these traditional methods where we prepare salt plates or we prepare a pellet for solids and liquids respectively, but sometimes we're going to use a newer module that we just got last year that's a lot more fancy and easier in some ways, but sometimes it doesn't give us as good a data, so I'll let you know which one we're going to use on a regular basis. But really these modules just kind of slide in and out. So I'm being careful. They're held in with magnets. And the first thing we've got to check is to make sure that the tip that's attached is the proper tip. There's two different tips that go here. This one's a flat tip, which we're going to start with a liquid sample and collect our data. And then eventually I'm going to replace the tip with the solid sample. So liquid sample is still pretty easy. What you do is we're going to test limonene. So here's limonene. I'm just going to take this out of the bottle with a pipette, and you only need to do 1 drop at the most onto this little window. You'll just see a window in the middle part of this, and you just want that drop there. If you've got a volatile liquid, you want to move as quickly as possible with this. But I've turned this top dial to clamp it down in such a way that you hear a click, and I'm going to do that again for you so you can see this. So I'm going to turn the opposite direction to release it. So one more time, I'm going to clamp down until it clicks into place. Here we go. Okay, do not turn this dial beyond that. You'll end up cracking the window down there. So when you hear that click, or feel that click, more importantly, that's when it's clamped down. All right, so that's ready to go. All you have to do is collect the data for this. Pretty easy for liquid samples. Collect the data, you're done. Now I'm going to release this, and we need to clean this as soon as possible. So liquids are fairly easy to clean, and you just take one of these lens papers that are available on the side of the instrument, blot as much as you can onto this lens paper. Don't use chem wipes. Apparently they're not good for the window. These are lens paper tissues. And not only that, I'm going to take another piece of lens paper, and I'm going to wet it with a little bit of isopropanol, which is always back here, just to make sure that all that residue is gone. I'm going to clean the tip as well as I can too. All right, so let that dry. So now I'm going to show you how to do a solid sample, which is a little more involved. We're going to have to take this base plate off and switch to the solid tip. The solid tip is different versus the liquid tip. The liquid tip is flat at the end. The solid tip has got a little concavity at the end of it. And so these just unscrew like so. And I'm going to try to not let it drop on the window when that happens. And then the other one goes on. Okay, and I'm going to store the other one in a little spot for it. Base plate goes back on. And now I'm going to take my solid with a spatula. And what we've learned to do is to put just a dab, a good healthy dab of our solid compound onto the center part of the window as best as you can. I'm going to put the cap back on. We're going to clamp it down until it clicks. And the idea here is to try to wedge or compact as much of the solid organic compound as possible into that tip. So I'm going to do this several times where I just kind of clamp it down until it clicks, release it, push a little more of the solid onto the window, clamp it down. Really, I do this 5 times, I think I end up doing, just to make sure that it's totally wedged into that tip before I start collecting the data. Okay, I think I'm going to do this one more time only. And then finally, I clamp it down once and for all. Collect the data, however you have to do that. And then the cleanup, of course, comes next. We're going to release this again. Sometimes if you want to, you can swing this out of the way so that what we traditionally do, and this is going to be really loud, I'm sorry on the video, but we're going to use this little hand vacuum to suck up as much as we can of the solid for starters. So let's go ahead and do that. All that I've done is I've just sucked up what I could with the vacuum. Now what I need to do is make sure that I get the last traces of that solid away from that window. And once again, I'm going to use isopropanol. Wet it first. Get what I can. And also the tip is likely to have some compound wedged into it still. We spent a lot of time doing that. Actually, it looks pretty good. You can either bang it onto the countertop a little bit, or you can use a spatula to dig it out. I don't see any trapped in the tip here, but nonetheless, I'm going to just wipe it clean with a little bit of isopropanol and then reattach it, and we're ready for the next sample. Okay, I want to mention a few things before we end this little clip. few more things. There's a light in the back. You can turn that on. There's a switch back there. This fume hood is always on. It's pretty weak, but it's always on, so you can rest assured that our vapors are being trapped up or sucked up into this hood. Always clean this when you're done with it. Don't leave it dirty. That's really important. And if you're the first person to run either the ATR or the other module, the transition module, anytime you switch between these modules, it's necessary to rerun the background. And if you're not sure how to do that, I'm going to have a screen recording on how to do that with software. But don't forget to run the background before you start loading samples onto this. Now, with the background run on the transmission module, you just simply have no sample in there when you collect the background data. With the ATR, what I suggest is you just clamp it down with no sample in place, collect your background, and then that's it. You're ready to put a sample on there. But otherwise, it's pretty straightforward to run these two modules. We just finished collecting the data for our liquid sample on IR. So all you have to do to clean these plates is to place them in this old desiccator that we have and squirt them with acetone. I'm going to do this on both sides. I also like to take a piece of a little chem white paper and scrub them on both sides too, just in case some of this stubborn residue is not coming off. But otherwise, that's the procedure for cleaning salt plates. It's pretty straightforward. Just make sure that they're dry for the next person before they come along and start preparing the next sample, but pretty easy to clean these plates.